Hello world! Welcome back to this tutorial on building a Linux from scratch system. Now in the last video we have finished chapter 8. We've installed systemd and some other stuff, and then we've configured the network and some system things like the console, and now as you can see here, there isn't much left to do. So today we will compile the kernel, install grub, and hopefully then we will be able to boot our system. So I'm excited, I'm looking forward to that. So let's jump right in. So I will create one more inside change root script. Still haven't come up with a better naming here. Okay, so today we will install from chapter 10 the package Linux, the kernel. Okay, but before we do that, we need to create our etc file system table. That's not difficult. Here we have to define the root device. It's an ext2 device. I haven't set up a swap drive, so I've turned that off. With this we can also access the boot drive. Yeah, that's chapter 10.2. Then we already come to the kernel. Okay, we start by calling make Mr. proper. That's a command that cleans up everything from it resets the code tree. I don't know why you should do that on a freshly unpacked directory, but I've had enough problems with failed Linux builds, so I will just do it, and I'm not going to use make menu config that I've copied from here. I will use make dev config, which uses the default configuration, because I don't want to bother with making all the selections here. I have made a video about compiling the Linux kernel, and I go into details a bit more there. So if you're interested in that, you can watch that video. With this we compile the kernel. Then we copy all the modules, the drivers and stuff to their target location, and then we already install the kernel to its location in the boot directory. what that system map does. We do a backup of our config file that we've created. I mean, if we do the default config, then it's a bit pointless to make a backup of the config file, but okay. Anyhow, installing the documentation. Okay, then yeah, this enables a few drivers for USB devices. I mean, this is in the chapter about the Linux kernel, so I don't know, I wouldn't think that this should be part of this script here, but okay, since they have it in that chapter, yeah, I will just do it like that. Okay, that's already all we need to do for the Linux kernel. And then we come to the bootloader. So to install the bootloader, we run grub install, and we will run that on dev sdb, which is our USB key. We might want to use this variable instead, but we are not passing that to the change root, so I will just leave it hard-coded here. Okay, then we only need the grub CFG. The configuration for our grub. The default selection will be menu entry number 0. That's we only have one, so they start at 0. So this is our default selection. We will wait 10 seconds. We will use the ext2 module because, well, our drives are ext2 formatted. At this point, this root variable here refers to the root where grub loads its data from. So this is the device on which grub is supposed to load the kernel. So this file here, you know, that's the location where we store the Linux kernel file, right? So if you remember here, here, that's where we put the kernel. So that's the location of the kernel. But I will remove this boot here because this location here is relative to the device, and if we mount sdb1 on /boot and then put something into /boot, it means that relative to the device, it's going to be in the root directory of that device. Okay, I hope that makes sense. I'm not sure if it's going to be HD0. We can test that in the grub shell. But yeah, the root drive was SDB1, so that's why I put a 1 here, because yeah, 1 is the boot drive. Okay. Then we need dev SDB2 is the root device. Yeah, that's our Linux from scratch device. Yeah, that's where the Linux kernel will then look for modules, for drivers, for system settings, and so on. Now we'll set that to read write. Now, in the system V branch of this series, we've already booted the system, and at this point we had a problem because when we are booting from a USB device, it can be just too slow. So we boot the kernel, and then the kernel asks the whole hardware of the system, hey, is there an SDB2? And then the kernel just gives up too fast. It just says, is there an SDB2? No? Okay. Then you get a kernel panic because the answer of the device is too slow. Because of that, I will put a root delay 10 here and a root wait also. Good. This looks good. Okay, then let us run this. Okay, this time, since we copy the kernel to the boot drive, and we also put the grub CFG on the boot drive, we need to also mount the boot drive. Okay. Okay, this all looks okay so far, except grub install error. Yeah, I forgot that. The problem is that this machine was booted using UEFI, and when a machine is booted using UEFI, then grub install also wants to use UEFI. And yeah, we haven't compiled UEFI support into it, and I have actually tried to do that before, but I didn't succeed in it, so I will just set target equals i386-pc. the equal sign. Okay. Let's do that manually. Okay. Okay, one last thing in the system V branch of this video series. I've had trouble booting the final system because for some reason, I don't know why, but the bootable flag on the boot partition was somehow not there. So I'm gonna print the partition table. Yeah, you see here in this column there should be a star for the bootable flag, and because it was not there, I had trouble booting it. So activate the partition 1, write the partition table. Okay, now it should work. Print the partition table again. Yeah, now it's bootable. Okay, so then we can try to boot this. Wait, I'm seeing something. Grub CFG seems to be missing. Strange. Also, I think this should be MS-DOS 1 because we've used a DOS partition table. Okay, now let's try to boot it. Put this little sticker here again to help the autofocus of the camera. I'm going into the BIOS. Well, technically the word BIOS is wrong because today's UEFI BIOSes don't provide any facilities for input and output. So yeah, BIOS is actually a wrong term here, but it's still customary to call it that. So MXtronics, yes. Okay, here's our grub. Okay, let's boot it. This looks pretty good. So the kernel is apparently booting. Okay, this looks like some... network name resolution, network time synchronization. They have failed, but do you see that down there? I can log in. I have a bash. I can echo something. Okay, I cannot ping Google. Well, that's not surprising because it was complaining here about some network problems. So let's see, IP space A, either 0 is down. Okay, so let's say network control up, either 0. System D network D is not running. And I typed UO instead of up. Direct firmware load for RTL NIC RTL 8168H-2.fw failed with error -2. Unable to load firmware. Okay. But what is with okay, but what is up with system D network D? System control start system D network D failed. Journal control -xe. Okay, it says system D network D service failed to determine user credentials. No such process. Failed at step user spawning. Lib system D network D. No such process. Okay, so this was at least partially successful. We were able to boot the system, but we had some trouble with the network. So let's see. Let's Google for this RTL_NIC/RTL, the Realtek network device 68H-2.fw. Okay. Download this. Now this is a firmware file, so this is a firmware file, so needs to be put in we need to put this in TLFS lib firmware. And yeah, let's see. I will also make this directory rtl_nick and copy this firmware into that directory also. Okay, let's try again. Okay, still network problems. Okay, let's try again. Network control up either 0. Okay, that's a different problem now. Link is down. It says here link is up. Oh. Could not ping Google because unknown host. Okay, let's ping something that doesn't require name resolution. Network is unreachable. System control start system D network D. Exited with error control. Journal control -xe. Okay, failed to determine user credentials. No such process. And here it says main process exited, status 217/user. So I've done some research and it seems that error message 217/user seems to have something to do with the user as which a service is run. So yeah, let's look into that. Okay, so this is a service file for the network D service. Okay, it says here that it wants to start the service as user system D-network. Okay, that's a bit problematic because I've started this system with a system V, Linux from Scratch book, and then after Vim I've switched to the system D, Linux from Scratch. So, I mean, system D-network does not sound like a user that would be in the user list for system V. So let's look at that. Okay, here's the code for creating the etc password file, and let's compare that. Okay, that's a different set of users. So we have root, bin, daemon, message bus, then nobody, and this tester user. And all these are missing. I mean, it makes sense that they wouldn't be in there in the system V Linux from Scratch, but here that's the user that we didn't have. So of course that makes sense. If this user didn't exist, then that could of course cause problems to try to run some service as that user. Okay, so save, exit. Yeah, let's try again. Oh, there was no error message. Yes! Okay, so that was very successful. We were able to boot the system, log in, work with a bash, do some network stuff. So yeah, this kind of concludes this series. But yeah, there's more to do. If you go to LinuxFromScratch.org, there's this point Beyond Linux from Scratch, and you can go to download, and there you can go to you can download this as PDF, I think, somewhere, but yeah, here's everything in one HTML file. And here you have this huge list of packages that are quite popular things like, let's see, SSH. Yeah, OpenSSH is here. And here, yeah, for these packages you have download locations, MD5 sums, and further compilation instructions. And yeah, I think I will make some appendices for some of these packages. Like, yeah, SSH would be very interesting to me because if you're going in the direction of IoT with something like this, well, IoT devices typically don't have a display or anything. So they would just sit somewhere and have some network connection. And yeah, then SSH is a very good system to log onto that device, and then you can work on it in a bash and have a nice working environment. So I think SSH is really a good way for communicating with IoT devices. But I would also be very interested in the graphics server, maybe Wayland, maybe X11, I don't know. Of course, then when you do that, the next question is, of course, the desktop manager. I personally like KDE, but GNOME is also very popular. I mean, these days there are so many desktop managers, it's crazy. But yeah, I think there is enough to go into after this, so don't worry, this series will continue. So tune in next time. If you liked this video, like it, share it, subscribe, and see you next time.